natural resources. So delayed na to. Over 30 years of experience in natural resources and environmental research, conservation, education, and development at the national, local, the Philippine, and international levels. His works focus on issues related to natural resources, conservation, climate change, and land degradation, or sometimes you use it as land conversions. Of course, he says he's a member of the IPCC, and today he is the Philippine coordinator of the World Agroforesty Center, or ICRA. Where is ICRA center today? Do you know?
Erie.
Tama ba? Diyan lang sa tabi, no? Diyan sa Erie. Since 2004 of April, and it is a center devoted to promoting 3 farms, closing quotation, 3 farms. And concurrently, he is the scientific director of the OML. What is OML? Oscar M. Lopez Center. It's a private foundation whose mission is to promote research on climate adaptation and disasters risk reduction. He is also currently an affiliate professor of the University of the Philippines, Los Baños. So he never separated, severed the ties. He never severed the ties away from the university. He will always want a mentor, he will always be a mentor. And for this afternoon, he will again, and we are all honored, let's give him a big hand to give us this lecture on climate change. Dr. Rodel Lasco.
Thank you so much, Susan. That was so generous introduction. And to me, it's really more of a homecoming. As you know, Dr. Chito Protasio, one of my mentors and professors in 4135, Dr. Chito, ano? And of course, a colleague and friend as well. So, and I think Dr. Pan Fernandez was also one of my teachers in, crop sci, probably, or I forgot which. So anyway, in my desire to learn about forestry, agroforestry, and combine the two, I took a lot of basic courses from agronomy and horticulture. So I consider myself at least half an alumnus as well. Now moving on to here. So let's first of all just to give you really overarching view of the world. There are 3 important environmental agreements that happened last year. So 2015, very significant in terms of the major worldwide agreements. And I would say the umbrella agreement would be the Sustainable Development Goals, if you're familiar with this, most of you. If not, it's nice to be familiar with this. It is the global agenda for what we want to do as a global community. There are 17 goals in all. And related to that, at 2015 as well, September to be exact, we also have the Paris Agreement, diba, on climate and FCCC. So SDGs, 2015, Paris Agreement, but not only that, there's one more. Okay, well, before that, the Paris Agreement tries to keep global temperature below 2 degrees, preferably 1.5, 2 degrees. But not only that, there's one more that is probably not too familiar to many, which is the Sendai Framework, which is on disasters. Also happening in 2015. So magkakasabayan, no? So 2015, a very key year. And what I'd like for you to appreciate is that there is a connection between all of these agreements, right? There's a connection between the desire, the ambition to go for sustainable development, expressed in 17 goals, the UNFCCC Paris Agreement, and finally, especially for the Philippines, disaster is so very important. So the Sendai Framework for Disaster Risk Reduction. So we have to explore if there's something new, if there's something that we want to research on, perhaps the nexus, the interrelationship of these 3 agreements is, well, to me at least, a very interesting topic. So, yan ang context, yan ang global context. For example, linking SDGs and BRRM, Goal 11 of the SDGs wants us to have cities and human settlements that are inclusive, safe, and sustainable. So yung safety. So this is related to DRR, or disaster risk reduction. Just to look at the global data set of natural disasters, really, more than 100 years of data, you can see from here that it's rising dramatically, right? Of course, just because there are so much more people today, but at the same time, with climate change, we expect more and more extreme events leading to more disasters. So storms, flood, drought, these three, blue, yellow, and light blue, all of those are related to climate. So there's a rising case of or incidents of natural disasters, and also the number of fatalities and number of people affected. Well, we have earthquake and tsunami, but at the same time, notice storm, flood, extreme temperature, even landslides. All of those are related to climate. Flood, drought, storms, these are total number of people affected. So this is, as we all know in the Philippines, a very important issue. Economic losses, likewise, mainly earthquake and tsunami, but flood, storm, droughts, you combine all of those, it's much higher than earthquake and tsunamis. So this is the connection, and the connection between SDGs and climate change is expressed in Goal 13, which is to take urgent action to combat climate change and its impacts. And just quickly flash the goals under goal, or the targets under Goal 13: strengthen resilience and adaptive capacity, integrate climate change into national policies, and improve education awareness, and so on. So we see the connections between all of these, and I think this is the broader backdrop by which we must talk about climate change, cropping systems, and so on. All right, so let me now go into climate change, and this part will draw heavily from the IPCC Fifth Assessment Report, AR5, it's called, the physical science basis. And we know that the planet is warming. Unless you're hiding in a cave for the last 10 years, you know climate change is happening. You watch the movie, you see the documentary, you saw National Geographic, etc. So just quick flash of this. So the planet is warming, sea level is rising. These are all historical data sets, last 100 years. These are not models, these are all historical data. And Arctic summer ice, in other words, glaciers and polar caps melting. CO2 emissions, the most important gas, CO2, greenhouse gas, CO2, rising and will rise continuously all the way to the future, next 100 years. And so here's the projection, here's the future. Based on the latest IPCC report, the worst case scenario, next 100 years, temperature may rise up to 5-6 degrees. Best case scenario, which is what the Paris Agreement is trying to attain, 2 or less degree centigrade. So this is the best case. Most likely we won't attain this. The pledges are so minuscule compared to what's needed. So our trajectory is more headed towards this way rather than this. So this is very scary, 5 degrees, right? If you're, people are thinking, and I tell this to my 275 students, what's 5 degrees or 4 degrees? That's probably the question of some. I woke up 25 degrees this morning. Lunchtime is 32, 35 degrees, so that's a 10-degree swing within one day. Why should I worry about 4 or 5 degrees in 100 years? Well, that's not the right analogy. The better analogy is when you have a fever. Normal temperature 36 degrees. You have a fever, increase it by 1 degree, 37, 38, what do you feel? Warm, feverish, 39, 2 degrees. How do you feel? Or what do you feel? Terrible. 40, you'll probably be collapsing, convulsion, and 41 would probably be dead. So that's the better analogy of the temperature of our planet. So it's a warming world, temperature rising all around, wet and wetter, very difficult for rainfall and precipitation. The models are not too uniform, it's ambiguous. Some are saying drier, some are saying hotter. In the Philippines, most models showing wetter, right? Hotter and wetter for the Philippines. Sea level will rise perhaps up to a meter. 1 meter seems not too high, but again, the impacts of that on flooding, on so many other things, mangroves, etc. Huge. Philippines, same thing. Our Pag-asa modeling work showed rising temperature up to about 4 degrees, depending on the model, in the next 100 years. So again, just quickly flash all of these. Seasonal rainfall, as I've said, the story more difficult or more ambiguous. We cannot tell exactly, but mainly mostly wet and wetter moving forward. So we are in a crossroads. That's the point. Where do we want to go? Do we want to go more than 4 degrees? Do we want to go 2 degrees or less? This is the decision confronting the planet right now as we try to tackle climate change. So how do we respond to climate change? There are 2 ways to do it. One is by adaptation, the other is by mitigation. Mitigation is reducing greenhouse gas emissions or concentration in the atmosphere. Adaptation is adjustment to the impacts of climate change. So we'll tackle them one at a time. Let's start with adaptation. And this is now based on the Working Group 2 report of the IPCC, mainly. The main framework used by the IPCC is looking at hazards, vulnerability, and exposure as the main drivers of risk. So it's a risk framework. And those risks will have impacts. And, well, all of this, it will be dependent on natural climate, of course, natural variability, as well as anthropogenic or human-caused climate change. So emissions are here, it will affect climate, there will be impacts because of all of these, and that could affect our socioeconomic processes. All right, and so now moving forward towards food, crops. This is the framework also in the IPCC report on food. Looking at the drivers, so it's not just climate. I do know this, right? In fact, in most cases, climate is not the most important. There are other drivers out there that perhaps are affecting yield and productivity even more than climate. But climate is important, and it affects various production aspects, non-production aspects, and ultimately, a lot of course, policymakers are concerned with ultimately food security, okay? Whether we can feed our people. So that's the, okay, and just to summarize some of the findings of these are different chapters of the report. So the report is very thick, as you all know, but I'm just essentially choosing and picking the most relevant to us this afternoon. So the impacts of climate change will vary by region, declining in productivity to be experienced is already evident according to the report in the case of rice production. Most models in fact showing lower rice yields as a result of shorter growing periods. And there's really a bunch of literature on this. Chinese scientists really conducting a lot of research on this. There are a number of regions already here that hit stress limits of rice, and you know this more than me. However, this is the sort of the fly in the ointment, or the thing that's so uncertain, CO2 fertilization. Because we know that the more CO2 in the atmosphere, then supposedly it will lead to enrichment and CO2 fertilization effect on the growth and yield of crops. So it is very, very problematic. But anyway, sea level rise will also inundate a lot of low-lying areas, especially true of the large deltas like the Mekong River Delta and other deltas, major deltas in Asia, including Bangladesh. But there are also many potential adaptation strategies out there, but we need more, of course. Okay, so now we look at here the international food prices. So part of food security is not just production, as again, most of you know, it's also driven by the ability to purchase or to have access to the food. Again, sorry, it's a bit small, but these are just showing the spike of commodity prices. This is based on the FAO Food Price Index, the red. This is FAO Cereal Price Index, and this is the U.S. Crude Oil Index, and you can see how the prices of food is also tracking the price of crude as well. But you see, there's really higher food prices in the last 10 years, more or less, there was that rise in food prices. Okay. And if we look at now the impact, the yield impact of climate trend, this is recent climate trend. This is not climate change yet. This is just the current climate and the recent climate trend. So what the IPCC did was gather all the literature on this issue, on this topic, and they look at all the number of studies showing whether in the last few years, whether it is -10 to -5, -5 to 2.5, 2.5 to 0, in other words, no change in yield, not significant, greater than 0, in fact, positive. So what he is saying is that most studies show that there is a slight decrease in yield in the last few decades of the climate. In fact, if you look at this is the wheat, soy, rice, and maize. And so this is 0. So negative, that means the yields have been declined globally. This is global, based on global data set. So most of the research studies showing that globally there is a decreasing trend in terms of wheat, soy, even rice, yield, and maize. And this is the 90% percentile from here to here. So you see the range. This is for rice. Okay, so maybe you know why better, but this is just the data globally. Now, in terms of the simulated change, now this time this is climate change. In terms of the simulated change as a function of local temperature, maize yield, this is temperate region, this is tropical region, and this is 1, 2, 3, 4, 5 degrees rise in temperature. So simulating climate change. If temperature rises by 1, 2, 3, 4, 5, based on so many studies, so all of these are studies, because the IPCC synthesizes studies. The IPCC doesn't conduct studies on its own, but rather synthesizes available body of literature out there. So all of these points are coming from hundreds, 200 plus studies. So showing that the trend, in terms of the many simulations conducted in the tropical region, is that maize yields will decline with increasing temperature. So these are the, so that's for, and this is for wheat. So it's more dramatic in the decline, I mean, is in the tropical region. That's again the temperate. So in the temperate, it's even probably going to be a bit of an increase. Again, it's not all losers, there will be winners. And Canada, for example, Russia, a lot of the very cold places could actually be winners because of climate change. And of course, the most interesting perhaps for us is rice. So here's the picture for tropical regions, 1 to 5 degrees. By the way, this is no adaptation, and this is when we do some adaptation. So that's why adaptation is so important, because if we adapt, there's even a chance of increasing yield. If we don't adapt, then it is declining. Okay, so but again, it's a bit mixed, right? It's not too certain, because it can be positive, it can be negative, depending on certain assumptions. So there's still a lot of uncertainty, and obviously the scatter of the data, as you can see from all of these data points, is wide. It's really wide. So we need to narrow it down, and that's by research. And these are the things I hope that will challenge some of you masters and PhD students to go into this kind of research. Now, this is the projected changes in crop yields due to climate change over the 21st century. So this is up to 100 years. Okay, so for the blue one, the more blue it is, the increasing yield. The browner color, the decreasing in yield. So here you see that, so again, a lot of studies, some studies showing almost, the number of studies showing increase is almost the same as the number of studies showing decrease up to 2029. But starting at 2050, 2030, and 2050, most studies showing declining yield compared to those studies showing increasing yield. And as you move ahead, as we move ahead even more, we see there are more and more studies. In fact, the studies are showing more and more, or greater and greater decrease in yield as we move to 2100. And there are less and less studies showing.
Is that projection?
projections. These are now computer simulations or projections, right? So this is just comparing or synthesizing the available level of information out there, the available simulations conducted worldwide. Okay, so this is very synthetic, very aggregated data. And the other thing is not just the yield, the mean yield, even the total yield, but the other very important thing is the variability of the yield. And this is, again, something we need to grapple with. It's not just the total number, but rather the variation of that number. And you can see that the variation, so for rice, so this is change in coefficient of variation of yield, and this is the projection midpoint. Okay, but these are the years up to 2090, and look at rice. The coefficient of variation, the change is 300%, threefold at this time slice, and here it's that. So rice from there, present, almost present. The variability, at least based on Tao, 2013, that guy really has done a lot of research on rice and climate change. And so you can see that the variation of the yield. In other words, sometimes it's very low, sometimes it's very high, and that's difficult, right? It's very hard to plan if your yield is very, very variable. 1 year it's low, 1 year it's so high. So how do you plan for such kind of variability? So I just want to flag that that's a very important issue, the variation. These are not IPCC reports. This is based on IFPRI. That's another city center like IRI. IFPRI is the Food Policy Research Institute. Their research 2050 irrigated rice all over Asia may decline by 27%, 1/4 decline by 2050 for irrigated rice. Again, most of our country is there, and I think some of you are not from the Philippines, but hopefully we'll see your country there. Rain-fed rice is less affected, based again on this simulation, negative 12% for the whole of Asia. So about half of the reduction of paddy fields or wetland. Okay, and next, this is again the story of CO2 fertilization, with and without. I just want to show how dramatic the effect could be, with and without. If the simulation is done without CO2 fertilization, for example in rice, without CO2 fertilization, the yield will decline compared to the baseline or compared to the present. It will decline by more than 10%. But if CO2 fertilization is included in the model, the yield of rice will actually increase. So if you're the policymaker, it will be confusing, right? So what story are you telling me? That we should prepare for climate change because rice will decline? Or are you telling me I should rejoice in climate change because rice yield will actually increase? So this is the big challenge for us scientists or us researchers. How do we convey the uncertainty message? How do we convey that we need to act, but at the same time, we still don't know exactly where it's going. So there's a bit of uncertainty, but as I've said, most models showing declining rice yield or declining crop yield as a whole in the next 100 years for tropical regions. But as to the exact crops, exact decline, a lot of these things are still very much uncertain. Here's some work by our colleague here in UPLB, Dr. Ino Lalsigan, showing their work for rice, increasing temperature 0.5, 1.5 up to 3 degrees warming, 14% on the average for every degree temperature increase. In the dry season, in the wet season, lower 8% yield decline for every 1 degree rise in temperature. Again, these are all modeling simulation kind of work. And again, they also work on other crops. This is corn, sugarcane, peanut, tomato, in different areas. I think Ilocos Norte, Nueva Ecija, and Bukidnon. So, okay, so these bars are provinces, 3 provinces. Okay, and so IRI is of course doing a lot of adaptation breeding work. Here's, this is a very famous, I'm sure you have seen this, submergence tolerant rice, and already they are able to breed up for up to 7 days submergence. So very interesting work showing how genotype can be bred specifically to adapt to certain climate impacts. Okay, so that's the adaptation side. And just quickly, not too many slides, just 8 or so, to also look at the other side, the mitigation. Adaptation is more our concern in the Philippines because of the impacts, because of the many disasters we face. Mitigation is a bit controversial. You may have heard we committed 70% reduction in the Paris Agreement, and our president seems to be alarmed and seems to not keen on ratifying because of the 70%. But anyway, I am not a political person, so I won't comment on that. But anyway, that's the story of mitigation, reduction of greenhouse gas emissions. And as we look at the emissions, we see that the most important greenhouse gas is CO2, this one, CO2 from fossil fuels. But there's also a lot of CO2 coming from land use change, primarily deforestation, and even agriculture, as we shall see later. And then these are the other gases, methane, CH4, important also in agriculture. As you know, paddy fields emit a lot of methane. And then N2O, nitrous oxide, also very important. Fertilization and so on, those gases also are important in agriculture. And as we look at our sector, this is the sector most relevant to us. AFOLU, agriculture, forestry, and land use. They're all lumped together. AFOLU is what it's called. It's 24% of the global emissions in 2010 of 50 billion tons emitted every year, but this is 2010 data. Of that, 1/4 comes from agriculture, forestry, and land use. So it's huge, coming from our sector. In fact, for us here, the most important are so it's about 10 to 12 gigatons or billion tons of CO2 per year. And of course for us, livestock, soil, nutrient management, these are the important sectors that contribute to AFOLU emissions. Again, looking at the annual emissions of greenhouse gases, if you want to know exactly where it's coming from, so there's a lot of the red coming from the land use change and forestry. This next one, orange, is from drain peat and peat fires. But enteric fermentation, livestock, animals, also very important. Then synthetic fertilizers, manure, crop residues, etc. Rice cultivation, this one. So all of these are the important sectors when it comes to emissions. And if you want to mitigate, to reduce emissions, you have to look at all of these sectors. Ag emissions, 2005, again, just for you to have an idea, most of it coming from ag soils, enteric fermentation, manure management, and of course, rice cultivation. But there are technologies also already available to reduce emissions from, as you know, from rice, like alternate wetting and drying, as an example. There's also a lot of potential in our sector, both in agriculture and forestry. This is the mitigation potential. Depending on the price we are willing to pay. This is red line. If we're willing to pay $20, it's a cost. It's cost of mitigation, cost of abatement. Blue line, if you're willing to pay $50, and if you're willing to pay $100, that's the yellow. So obviously, the more money you're willing to shell out for every ton of CO2 reduced, the more potential you will have, right? So that's the total for agriculture and forestry, and these are the disaggregated or specific mitigation measures from cropland management, restoring cultivated organic soils, grazing land management, restore degraded lands, rice management, livestock, manure, agroforestry, regrowth. So these are the things that we can do to mitigate climate change. And just to note that Asia has the largest potential of all the continents grouping under the IPCC report. This is Asia. So especially for $100, we have the highest potential mitigation. So there are a lot of options. This is for only AFOLU, for agriculture, forestry, and land use. Okay, so finally my last slide, just so we have time for open forum. I'm sure you want to say something as well. Climate change, just to summarize, climate change impacts on crop production and food security. This is an opportunity for action. As I mentioned to you, there's a lot of uncertainty. There's a lot of unknowns out there. It's, if you want to really contribute to science, this could be an avenue for you to really make a difference in terms of teasing out, and I mean, in terms of knowing and finding how our sector will be affected by climate change. There's also a lot of opportunity for adaptation, what adaptation measures we need to do. As we have said, IRRI is doing the breeding work for rice, but for other crops, I don't know if how many scientists or researchers are looking at other crops and how we can adapt to climate change. And finally, my last point is, as we have seen, there's an opportunity as well for reducing emissions for crop production systems. In fact, in terms of money, there's more money here. There's already a booming, at least before Paris, and hopefully after Paris, there's a booming market for carbon sequestration. It's more than $100 billion a year of money changing hands to buy carbon credits, so-called carbon credits. So there's a lot of potential here and still untapped, sorry. But anyway, these are my 3 key points that I hope will start the ball rolling. So again, thank you so much.
Thank you, Rodel. Thank you, Dr. Lasco. I'm gonna open for questions, comments from the audience. This is not, just so we can break the silence. Parang bigla, it's mind-boggling, no? Parang the graphs that he showed, he is my professor, yan ng exam namin, he will show you a graph, and you will interpret what that graph and what all points mean. And then that's a way you can get a 1. But there can be anything, you know, parang ganon siya, professor, so that's why his presentation is full of graphs. Now, your turn to ask questions to Dr. Lasco. Anyone? Carla, you have something to share? This girl, and this is my student, she's one of the most, she just mentioned that today, if I may, she was brought up in a very democratic way. Very, her parents are very generous. And she told them, my parents are communists, and I'm a socialist. And therefore, she's so sanay with expressing herself. I know you have a reaction. I read.
Sir, good afternoon. It's related with the last few slides that you showed to us.
Introduce yourself.
Sir, because you mentioned if we pay more, we'll reduce the carbon emission. And you said that Asia has the, how do I say, like highest potential to reduce the CO2. So it means that Asian countries have to pay more. But I think the most advanced countries we have are not found in Asia. Very few countries are in Asia.
Yeah.
And I'm just curious, sir, what will the other countries not in Asia contribute to that? Because I think they are benefiting from us as well. And I think that's what our president is concerned about.
Yeah. Okay, well, thanks for the question. I think for clarifying, thanks for giving me the opportunity to clarify, because it doesn't mean that if that's the cost, we will pay it. It doesn't tell us that. Okay, because really what's happening right now is that even in that old Kyoto Protocol, it was supposed to be the developed countries, the industrialized countries, who will pay, not us. We're not required, in fact, to reduce during the previous agreement. The idea there is that common and differentiated responsibility is the main principle. Common, everybody has a responsibility, but it's differentiated depending on your historical contribution. And since and up to the present, most emissions come from America, for example, from the US, from Europe, and Japan. So they committed to reduce during the Kyoto Protocol. We did not commit anything. Now, for the Paris Agreement, yes, we had a commitment, but that commitment is very soft. It's practically a non-commitment, because what we said there is this commitment of 70% is contingent on external funding. In short, give us the money, we'll do this. Don't give us the money, we won't do a thing. So that's how I interpret our commitment. So you're correct. It's very unfair. And this is the issue of justice. There's also the climate justice discussion. And we don't want us paying for the emissions emitted, of course, by the developed countries. And in fact, that's the whole debate. That's why UNFCCC is very contentious. That's exactly the crux of the matter. Who will pay? Who caused it, who will pay? And right now, that's where we are. The debate on who will pay. But obviously, developing countries like us are not willing to pay. Because number one, we didn't even cause it. Number two, we're one of the smallest emitters. Okay, and really, we don't have money, even if we want to. Okay, so I don't think we will be forced anytime soon to really pay all of this. Okay. Yeah.
I think, okay, Edna.
How much is the GHG contribution of the Philippines?
Yes.
And then the next question will be, even if it's a soft commitment, the fact that we, committed to reduce by 70%, what was the basis for that 70%?
That's an interesting question.
It entails us to reduce by that much.
Yes. The second question is, for me, the easiest to answer. It's because I don't know the answer. I've been part of the consultations initially, but the final number, I didn't know where it really come from. So I don't know. In fact, I think we should revisit the number, just because what's the basis? In short, what's the transparency? How was it really calculated? So I'm not sure where it came from. But the other question is 2 tons, more or less. 2 tons carbon, CO2, excuse me, per Filipino, 2. For an American, is 20. So they are emitting 10 times more than an average Filipino. And how much is our total emission? Less than 0.5%, if I remember right. But definitely less than 1%. I think even less than 0.5% of the global emission. In short, if we emit 0, nobody will even notice it, that we stop already. So we are very, very tiny fraction of total global, yes.
Because if we are that small a contributor to this pollution, why is it that we are very aggressive with, biofuels, Clean Air Act, so many, like constraints?
Clean Air Act, Water Act. Well, I think what's driving the Water Act, the Clean Air Act, I don't think that's climate change. Because there's another law, as we know, on climate change, which is the law on 2009 Climate Change Act. So I think perhaps Filipinos are just more environmentally aware. There's a lot of civil society groups here advocating for environmental conservation. Now the other question is a bit different. The question of renewables and biofuel, etc. Why are we into that? Well, already in Southeast Asia we have the highest level of generation from renewables. We're already very high as a country. So it's been a policy for so long. I guess again, there's a lot of awareness and consciousness in this country, in our country, that we need to go green, be more environmentally sound. A lot of us are afraid of coal, for example. There's a lot of demonstration whenever there's a coal-fired power plant being. So I guess it's the values of society as a whole is how I would put it, because it's been there for a long time. We are the second largest generator of geothermal, for example. I think we have the largest integrated solar power plant in Southeast Asia, up there in Luzon. So we have a lot of renewables as well. So, but if the question is, why do we need to mitigate, even if we're so small? I think, again, that's a different twist. Because our main interest is adaptation. We are the country, one of the most vulnerable, always top 3 most vulnerable country. We need to advocate for funding so that we can adapt. But how can we get funding for adaptation if we don't show that we're also contributing to mitigation? So I guess that's how I would put a spin on it. We are trying to mitigate, not because we're huge, we're small, but because we want to say, okay, we have participated in mitigation, but really give us the money, because we are one of the most vulnerable, and we need some support so we can help our people adapt. Maybe that's the strategy. That's why we're also into mitigation, even though the main goal is really adaptation for the Philippines.
Yeah.
No, this is something to clarify. Please clarify, to give you the chance also to clarify. When I was a student, I do not know, ano ba yung carbon trading? And how do you mitigate? May tinitrade doon yung carbon, yung hangin. Can you please explain to us in basic words, like, ito yung puno, itatanim doon, babayaran. Tapos, ang ginagawa si Dr. Lasco, habang nagkaklase kami, nagsasagot siya ng phone, oh, I just mobilized some few dollars. Bayaran na tayo ng ganun. Please explain to us that mechanism.
Well, the mechanism is really simple. The principle, I mean, it's just that when you emit 1 ton of carbon, then you should also sequester or reduce 1 ton of carbon. So how do you do that? If I am a Japanese company working in Japan, I can of course improve my facilities, make my engine more efficient. But since their efficiency is so high already, every improvement of efficiency costs so much, $100, $200 per ton of carbon. But if they go to a country like the Philippines and say, okay, you plant 1 hectare of trees here in the Philippines to sequester 1 ton of carbon, it will only cost, say, $5 per ton of carbon. And so there is that possibility of trading carbon. We will plant the trees so that we can offset or recover your emission. But there's a lot of debate on that because people are saying, well, why will we allow you to emit and we will sequester your carbon? So you develop and we're not going to be able to use the land, etc. So there's a lot of debate as well. But that's the basic concept. You allow a person or a company to emit, but that person will find a way to get back to capture, to sequester that carbon. It's the same principle. You fly Cebu Pacific. You check the box. You want to do offset of your emissions when you fly. WWF will plant trees for you so you can offset your emissions when you fly to the plane.
So you give the money to them to plant the
To
trees.
plant the
In
trees.
effect, the trees do belong to the Philippines now, or
That's a part of the debate. The rules are not so clear. It's not only, by the way, it's not only trees. You can do the emissions in rice. You can say, okay, I'll do alternate wetting and drying in this 1 hectare of rice. If I do alternate wetting and drying, it will mean reducing emissions by X amount. You can sell that. I mean, again, in principle. Okay, in principle. Or you can do less fertilizer. You're doing nitrogen fertilizer, emitting nitrous oxide. You shift to organic and perhaps lessen your fertilizer. The difference of that, again, in principle, you can sell in the carbon market because you are reducing your emissions. So a lot of these things, in principle, that's the key word. But in reality, it's so hard. Okay, it's so hard.
Okay, Dr. Putashi.
At the start of your lecture, you said that you weren't really sold on the Paris Agreement because of the pledges were quite small. And so I was really surprised that our pledge was like 70%. So what was the pledge of the other countries?
Well, the others obviously are much smaller than us. And so when I said that, I am for the Paris Agreement actually, but what I'm saying is all the pledges are not enough. So there's a website, you can check this, which keeps track of all the pledges so far. And whether these pledges are enough to keep temperature below 2 degrees. So based on this pledging, so far we fall far short as a global community. So that's the problem right now. We need to pledge more. Not us, I mean, not Philippines, but humanity or all the nations need to pledge more to meet the 2 degrees target.
Sir, with the current government not really agreeing with COP21, what's our plan in Marrakesh for COP22?
Again, it's not for me to divide the plan of our negotiators, but see, the problem is, this is the only game in town. It's not like basketball, there's a barangay liga here or there, and you have to choose, I'll go to that league or to that league, or NBA, PBA, if you're the player. Unfortunately, for climate change, there's only one ball game, which is the UNFCCC. There's not another ball game. And so if we don't join the ballgame here, we will go nowhere because there's nowhere to go. All the countries, China, Russia, US, Japan, etc., all of them are on board. Their pledges are not enough, okay? But at least they are seeing the Paris Agreement as the main agreement to address climate change. So I guess we have no choice. We have to be there. So we have to be there. We can re-examine our 70%. We can recalculate it. It's not too late because we haven't ratified, number one. And even if you ratify in the Senate, we can still change it. So it's not too late. And we as scientists should have a voice on that percent, whether 70, 60, 50, or even more.
Okay. Seems like it's a very complex issue, and it's a very global and even beyond global. I just wonder if I may ask, recently or last year there was a movie called titled Cowspiracy. Are you familiar with that? It's like there's a conspiracy in all these changes in climate and destruction of the environment, and it talks about industrial agriculture as the highest contributor, especially industrial animal production, especially in other countries. And there it says that there's conspiracy because they don't want it known, including this non-government or foundations. They don't want it known, and they are mum about this contribution. They just say about climate, this CO2 or carbon increase in the atmosphere. But when you make the calculation, if you change your diet, you can actually reduce this contribution and protect the environment, etc. But there it says that even Greenpeace does not have in their website, or they don't discuss openly about the contribution of animal agriculture for many reasons. It's like conspiracy theory at work. So I just wonder about that. If there is in the calculations in the model something about that, or the contribution of just crop-based diet in mitigating or responding to climate change.
I didn't see the movie, unfortunately. I'm not a frequent moviegoer, but anyway, I think the animals, livestock, beef, burger, etc. I think there's enough evidence. In fact, one of my students in 275 actually did a report on how much water, how much carbon footprint all of these meat, eating really the process. So I guess it's known, it's out there, people are aware, and that's why changing lifestyle is a very key way by which we address climate change. We cannot just keep on carbon footprint, not just carbon, but the whole Earth's footprint. You know this story about footprinting, right? And we need 2.5 planets if we are to survive, because we are using the carrying capacity and all of these concepts. We don't have time, of course. That's another issue by itself. But I think all of these are related. We have to see this big picture as well.
He's a good timekeeper. But if there's one that wants to make a very short comment or question.
I'm okay. I don't have any schedule. I'm worried about people who may have
They're
classes
not worried.
No, I'm thinking, I thought saan si Ellen Ross? Did we distribute Ma'am Ross ng paper for them to write their questions?
Yeah, they can write on their own paper.
You can write in your
And later on, we can give it to Dr. Lasco for his insights, his questions. Is there any other who wants to say here or express their questions?
Yes.
Going back to the greenhouse trading, so far, has there been any real trading that has happened? And which country paid and which country received the payment? Something like that, because it's been ongoing for 2 years.
In terms of what is known as the CDM, Clean Development Mechanism, under the Kyoto Protocol, China got most of it, Brazil. The Philippines, we got a few. For example, with the Bangi, the windmill. Yeah, there's some credits to that. And there's also a lot of credits going to methane capture sa landfill, yung methane emission from landfill. But zero credits from forests. There's not any single forest project getting credits in the Philippines. So that's the situation right now. So globally, most of the trading is happening in Europe, not including developing countries. In other words, European country to European country. I think more than $100 billion. Then the rest, to CDM, it's called market, compliance market. You have to comply as a result of Kyoto Protocol. So there's some trading there, but mainly methane emissions, landfill, wind power. But there's, as far as I know, nothing on agriculture, nothing for sure, nothing on forest as well. So we are in a way lagging behind industries when it comes to carbon credits.
I think the bottom line is, I mean, we can have this climate change movements. But there's also a call for our individual contribution, for preparedness, for mitigation, and whatever other actions can help us survive. Because they say that it's no longer 20 years that we will be underwater. No, 50 years actually, and then they said it's 20 and now 18, and I think even less, that our low-lying islands will be underwater already. And so there's many factors, but our lifestyle can really help in that, including, with the United Nations. They invited this group of meditators, Brahma Kumaris, and they're saying that for climate change, we need to address our consciousness, our lifestyle, our consciousness, because that will become real, and so we have to also feel or develop ourselves in terms of consciousness. And you cannot put numbers there. You cannot put it in the equation. So I think it's kind of it's a different ballgame actually. So if there are no more questions, we would like to invite Dr. Rodel to receive our appreciation. Maybe invite